Page 48. What we're going to be doing is we are going to be looking at rational exponents. So whenever anybody says rational, even though that covers basically all of the negative, positive numbers, it also covers numbers that come in the form of a fraction. And so even though like the number 2 is rational, usually when you see the word rational and you're looking at math stuff, it's probably referencing something that's in the form of a fraction. So what I have here is I have a power, x raised to the power of n over m, and I have a rooted expression, and these are equal. So I want to give you a little bit of background on here and hopefully make this a little bit more understandable. We're used to seeing the square root symbol, and we can have whatever we want under it. I'm going to put a perfect square number under there. A square root symbol, when you hear the word square, hopefully you're thinking of the number 2, the exponent 2. Usually we will put the number of what root we are taking in this spot right here. And but when we do the square root, because that's the one that's used the most often, we just don't write it, and it's assumed when you see the symbol that there's a 2 here. If you were taking the cubed root of something, I'm going to put 125 here, then I would have a 3 right there in the root spot. So that's a thing. Now, even though this number doesn't have an exponent written, you can assume it's a 1 if there's nothing written there. So this is a 1. If I was going to use the rule I showed you here to rewrite this rooted expression as a number raised to a power, it would look like 125 raised to the power of 1 over 3. The 1 coming from the exponent that's under the radical symbol and the 3 coming from the root. So if I were going to write this second example with a rational exponent, it would look like 25 raised to the power of 1/2. And if you put that in the computer, 25 raised to the power of 1/2, it will give you the square root of 25, which is 5. So that's kind of interesting. The cubed root of 125 is also 5. 5 times 5 times 5 is 125. So you're going to have to be able to write numbers that are in rational exponent form to rooted form. And then if you start off with a root, you should be able to convert it to a rational exponent. For instance, right here I have x to the 1/2 power. I'm going to rewrite that as x under the radical symbol, and then we have the square root. For the first example over here, if I have x to the power of 1/5, remember that the denominator is the root. So I'm going to put a 5 here, and then x to the first power is underneath there. Is it important for the first power to be written? No, but because this is the first time you've seen this, I kind of just want to make sure you know where those numbers are coming from. If you look at b, remember that under the radical symbol I have w. The root is here. The exponent 2 goes next to w. Go ahead and do c and then a and b, and pause the video, and then you can come and check your answers when you are ready. For c, you should have had the 7th root of t cubed. For g, you should have the 9th root of g to the 4th. And for b, you should have the 10th root of m to the 7th. On the next page, we're going to start off with a rooted expression, and then we have to change it to a rational exponent. Remember, always with this, your root goes on the bottom of the rational exponent, and then n goes on the top. So that's interesting. If you look at a, you have the square root of 5x. So I actually, if I wrote this, I would make sure that my 5x was in parentheses, and this would be raised to the power of 1/2. 1 because this is all of that is to the first power, and then the 2 comes from the root spot. B, W, raise the power of 2/3. The 2 goes on top, the 3 goes on bottom. Go ahead and do A and B. Again, pause, and then come back and check your answers with mine. Okay, for A, you should add 7A raised to the power of 1/2. And for B, you would have T raised to the power of 3/4. What I have on this, the last 2 pages of these notes, which is really nice, is several different practice problems for using the rules of exponents. So you'll see the product rule, the power rule, the quotient rule, the 0 power. All of those things are on here. This is just practice. You can look at that on your notes, and then if there are any questions about any of these, if you want me to make a video of one that you're stuck on, you can just send me a message and I would be happy to do that. Other than that, this video is over. On the 4th page are the solutions. So